Welcome to the Gestalt IT Rundown, where each time we meet, we run down the IT news of the week with a variable degree of snarkiness. I'm your host, Stephen Foskett, and filling in for Tom Hollingsworth, who is at Security Field Day this week, is my good friend Max Mortellaro. Welcome to the show, Max.
Thank you. Hello.
It's always great to have you here joining us on the Rundown, and it's always great to bring all the IT news of the week to the people out there. I will just point out that today is National Fast Food Day here in the US, which I guess is every other day as well. So let's go ahead and get into the stories of the week.
Absolutely. Thank you, Stephen. So the first story is around Ananda networks. At VMware Explore Europe, VMware announced a new SD-WAN client alongside with the acquisition of Ananda networks to accelerate the SD-WAN client development. The acquisition includes Ananda networks team, products, and intellectual property. Why is this important for VMware, Stephen?
Well, we've been talking to Ananda for a little while with our networking field day and Gestalt IT coverage of networking. And this stuff is pretty cool. It represents sort of that next generation wave of SD-WAN that is very much oriented toward the breakdown of location-based devices. In other words, it meets the modern world where you kind of don't know where people are or how they're connecting or what kind of connectivity you have. There's a bunch of solutions in this space, but Ananda had one that worked particularly well at finding interesting and useful routes between people. So, for example, I'm here in Ohio at the office. You're in maybe Prague, for example, at your home, and you want access to stuff here at the office. Your client will find a good route. It will try not to go through proxies and so on. And it actually uses a little bit of artificial intelligence to do that. So all this is to say is that this is a very clever product, but maybe not a product that could stand alone very well. But frankly, for a company like VMware, which has a lot of networking skills, but also has a lot of customers who are have a very distributed workforce, lots and lots of distributed servers and interconnections and so on, it makes sense to have a new SD-WAN client that can use this kind of intelligence. So I'm really excited to see where they go with this. I think that it was a good technology, and I'm glad to see it going into the hands of VMware, where they'll make good use of the technology. Max, you and I have been covering NetApp for a long time, of course, and we were very excited to see them announce BlueXP, which is a software control plane to manage data from the data center to the cloud. They announced this at Insight 2022, but we're hearing a lot more about it now. This service brings NetApp's historic strength in enterprise data to next generation applications. What should we make of BlueXP?
Well, Stephen, NetApp has been historically, as you say, doing a lot in terms of handling your data management. It's gone above and beyond just being a storage company in the sense of someone just manufacturing hardware, storage arrays. And I think that BlueXP is kind of the continuation, or rather the ultimate realization, maybe for now, of this idea that they wanted to achieve. I've had a look at that, and it is really interesting. I think that it is not just kind of a buzz in a way, the way they present that, but it's really a product with a lot of very worthy capabilities, particularly as soon as you start entering the world of multi-cloud, to say a controversial word, and you need to manage data which is stored on premises, on one cloud, on another cloud. Not everybody is an expert in all three clouds. Some people have more of a skill set for working on premises. Some may have been taking trainings on Azure or AWS, but you sometimes lack the, let's say, a kind of a holistic skill set to do things. And I really like that BlueXP provides a consistent experience when you need to do, provisioning applications, data migrations, protection, whatever. You do that from a single interface. It's really simple to use. So for me, it's a great thing. Of course, you kind of need somehow to be in the NetApp ecosystem, to take full advantage of that. Maybe NetApp will say it's not the case, but I think that if you've been historically working with a vendor, there's maybe a steeper, adoption curve there. But I really like what they do. So that's kind of my take on that. And to move on to the next topic, Kalray is a French storage accelerator which has announced that they're supplying Accelerator cards, which deliver high performance to enterprise customers. So this enters the crowded DPU and accelerator market for RoCE and NVMe over TCP storage access. What's the differentiator there for Kalray, Stephen?
Yeah, Kalray is an interesting company. It's got an unusual history. It came out of actually Renault, Nissan, Mitsubishi, Safran, NXP Semiconductors, and so on in France. And one of the interesting aspects of Kalray is that for the history of the company, which dates back now 15 plus years, they've been focused on developing their own ASICs that use VLIW, very long integer word processing, which as a computer data center geek is exciting because that was sort of an alternate way of doing massively parallel processing, dating back a long time. We saw this experiments in a lot of Unix systems, the Intel 860, for example. HP was looking into it, but Kalray has actually been bringing this to market for a long time, and frankly, it looks like the time has come. One of the things that we've seen recently is a number of these pretty cool companies talking about using GPUs to accelerate data because, of course, they have massive parallel processing. Well, one of the interesting things about GPUs is that many of them use VLIW as well, and that's kind of what Kalray is doing. So essentially, rather than having a special purpose ASIC designed around sort of a conventional RISC processing core, they're applying this massive parallelization to data processing to get really incredible results. I mean, they're talking about 2 million IOPS here for NVMe over fabrics, and that's really pretty cool stuff. So I am excited to kind of share the news about Kalray. I would love to learn more, and I think that this is going to be a space that is going to be increasingly another way to handle data processing and offloads for DPUs and other types of accelerators. Max, we've both, of course, followed Hammerspace as well for a while, thanks to their appearances at our field day events. Now, the Hammerspace global data environment has hit version 5, and the company is boasting that this solution can saturate Ethernet and InfiniBand links and extract maximum performance from data in the cloud. We've heard a lot about Hammerspace over the years, but what's new, and is this really realistic?
Well, Hammerspace is one of those companies I love talking with. They are really different than the others. The way they do things, the way they create, they have their global namespace, the way they are, the whole architecture and the concept behind that are somehow very different. I think that goes back into their history as well. Well, the short thing is yes, it is realistic, and I think that they are actually capable of delivering that performance. The other question is how is that going to be implemented into the field? What applications are going to be able to replicate those conditions, those testing conditions, to actually reach to a point where you can saturate that. Not all of the workloads are built for these. There may be some data locality issues. There may be some optimizations which are lacking on the other hand. So I think it is a good assurance for organizations which are either invested into Hammerspace or people considering to use the Hammerspace platform. Yes, nobody wants to buy a solution which is not really good on the performance side of things. But I think there's going to be maybe a kind of a reality check there, where organizations are going to be kind of reaching those limits. That said, I think that version 5 is really interesting. They've made improvements in terms of cloud object storage support. They're going in the right direction, even with some of their ML-based data placement and so on. So I think that definitely it's a real deal, and it's one of the companies that we should continue to follow. And with that, let's move to our last story today. So Alluxio announced today version 2.9 of their data orchestration platform, adding access control for S3 data, cross-cluster synchronization of metadata, and multi-tenancy. We've been watching Alluxio since they joined us on our Utilizing AI podcast. So what should we make of this announcement?
Yeah, Alluxio is an interesting company because this is really a data connections company. Many people know that my background is in storage, but of course, storage is increasingly moving up the stack. And now, more and more, we're using more advanced protocols, things like Amazon S3, for example, protocol in many different places outside of Amazon even, HDFS and things like that. But also at the same time, there's a lot more applications that are accessing data using different protocols. The problem is that you might have your data stored in one sort of data source, maybe an S3 bucket, and your data processing demands want a different type of source of data. Maybe they want to use HDFS or something. And so Alluxio provides a really cool transparent bridge. I mean, we could think of it as storage virtualization, but that really doesn't cut it. It's really sort of a modern data platform that allows basically any kind of application to access any kind of data, and in truly the meaning of the word data, not storage. And what this does is it really opens up a whole world of data processing to companies that are trying to make the best use of all this data that they're collecting. Now, this newest release of Alluxio does something which is pretty cool. For a long time, people have been sort of segmenting their environments. So basically, they'll have this Alluxio instance here to allow these applications to access this data, and this another instance here, and so on, for many reasons. Multi-tenancy is a key one, whether inside or outside of a company. But sometimes, you want to break down those walls. So one of the coolest features of this new version of Alluxio is that it can break down those walls, and it can have metadata synchronized, and it'll make it look like this instance has access to this instance's data. And then if you need it, you can just ask for it, and it'll go get it for you and make the connections and so on. It's kind of a cool data matchmaker. Another thing that this adds is access control with the S3 protocol, which again, if you've got a multi-tenant situation, that's very, very powerful, as well as a multi-tenant Kubernetes operator. So I think you can see that there's a common theme here, which is that increasingly these data lakes are being interconnected and accessed by different tenants, and we need to have better access control and better methods to enable data sharing between sources. So Alluxio is doing it. It does it really cleverly by separating metadata from data and managing the data paths and handling data movement and so on. Really, really impressed by where this company is going. And if you want to learn more, I'll just give a quick pitch. We actually talked to Ben Fan from Alluxio on the Utilizing AI podcast last year. So go over to Utilizing Tech and look for Alluxio there.
Very good. So now we are moving into our main story of today. AMD got the jump on Intel in the battle for the fourth generation server of CPUs, announcing the so-called Genoa line at SuperComputing 22. AMD's new CPU line is a massive upgrade with more cores, accelerator instructions, and CXL. And it comes ahead of Intel's delayed Sapphire Rapids Xeon announcement, which is widely expected early next year. So let's take a closer look at the AMD Genoa CPU line.
Yeah, absolutely. And this was a very, very important and exciting announcement because, of course, in the data center, although ARM is rapidly growing and getting a lot of attention, it really is still a two-horse race. And unfortunately, one of those horses has been stumbling a little bit recently, and that's Intel. They have tried to push forward their server architecture, Ice Lake, and now Sapphire Rapids, which everyone expects is coming next year. These things have been a bit delayed, and a lot of that delay has to do with Intel's tight coupling of processor design and manufacturing. And frankly, there's a lot of steps along the way that those things can get out of sync, and then everybody's got to wait. So that's what we're sort of looking at here. Essentially, Sapphire Rapids was supposed to be out first. It was supposed to be wowing us for a while, and then AMD was going to play catch up. And instead, AMD's here first. And in fact, to the extent, as we'll talk about here later, AMD actually is delivering CXL before Intel in their Sapphire Rapids Xeons. So it's pretty remarkable what's happened here in terms of the turnaround. And the processors themselves look really, really great. So just to be clear, the first Epyc here is the Genoa 9004s. We will see more different processor lines. So everybody expects that we'll see a Genoa X. They're talking about which has 3D memory Bergamo, which I guess would be a bigger data center, and Sienna, which is more for dedicated appliance. At least that's my understanding. I haven't actually been briefed on those things. I'm just reading the trade press like everybody. So everybody expects that we'll be seeing these next year. But for now, we've got sort of the mainstream, the Genoa server CPUs, and they're really, really impressive. We're talking about 96 cores. One of the biggest things for me is 12 channels of DDR5 memory. Also, another big announcement here is that they've implemented Intel's AMD AVX 512 accelerator instructions. We'll see how well that works. I can't wait to see benchmarks on that because they implemented it quite differently from how Intel would. And of course, I've got to say, as host of Utilizing CXL, that the big news for me is that it's got 64 lanes of PCIe 5 that can be used for CXL connectivity. So those are the big announcements in my mind. Max, what do you see in this launch?
Well, besides the fact that AMD is basing all of its CPU architectures on Italian city names, which kind of I love, but it also kind of makes me travel and lose my focus when I'm listening to that. I think that you highlighted perhaps one of the most important points there in those architectures. Not looking at what Intel has done or not done. The fact that CXL is available in those architectures is, at least in my opinion, is going to be maybe foundational or perhaps even transformational in, let's say, AMD's growth in the data center, perhaps in terms of adoption. It may not be for commonplace workloads. You may not need to deal with CXL for common general purpose workloads, but as soon as you're looking into high performance data processing, HPC, and so on, where you need to have the performance, where you need to implement, I don't know, I'm just thinking about some architectures which leverage, for example, persistent memory. The fact that you have that they have included that is really important, especially because it's in effect it is becoming an open platform compared to what we have on the other side of the pond, right? So that's where I see value there. Is there support, I think, for PCI Express 5, CXL. So to me, that's the big news there in the CPU architecture. Maybe one downside, and I think we were talking about that before as well, is these are really very power hungry. So that's maybe the only downside I see there. On the other hand, these are maybe CPUs that are really focused at those high performance workloads. So you're probably not going to see the power efficiency there.
So yeah, let's follow on that point, Max, because it's really important. I mean, we're talking about servers, CPUs that have a brand new socket, a huge power budget. I mean, we're talking about kilowatt servers potentially here if we're talking about a dual socket configuration, and that's just for the CPU. We just wrote a white paper, just published it actually this week over on Gestalt IT, Digital Infrastructure at Data Center Scale. Now, admittedly, that white paper was sponsored by Intel, but it was conducted by folks like me and Max, not literally, but metaphorically. And we researched the entire market and what are the decision points that go into building servers and server architectures. And for me, the fundamental thing that I've uncovered here in terms of data center and cloud servers is this idea of balance, that you want to make sure that you're balancing all the various factors that go into building a server and not just optimizing for the big wow numbers. I mean, Bergamo, we're looking at 128 core processor coming out next year, theoretically. Wow, that would be amazing. What are you going to do with 128 cores? Now, if you're a cloud service provider, maybe you're selling virtual private servers or something, that might be useful. But if you can only have 3 terabytes of RAM, I know, only 3 terabytes, or 6 terabytes maybe, then is that really going to be a useful thing? Because, you have to balance memory, CPU, I/O, all these other aspects of the system, not to mention power and cooling and cost. And what we found in our research, at least into the 3rd generation servers, was that the Intel value proposition was still really strong, even though they didn't have as many raw cores, because they had this balance. You could basically develop a server that would have the right mix of CPU, memory, I/O, accelerators, and cost, and deliver something on a scale that you need. So one of the keys to that solution for Intel was Optane memory, Optane persistent memory, which of course is falling to the wayside now. Now I think we're going to look for CXL as a way to kind of add another tier of memory to kind of close that gap, make sure the system has enough capacity of memory, maybe not performance, but capacity memory, in order to meet the needs of these incredible numbers of CPU cores that we're seeing. Another thing, as you mentioned, is PCIe 5, which of course is faster than 4 or faster than 3. And they have more channels. That really helps as well to bring enough I/O in to feed all those cores, et cetera, et cetera, et cetera. Now, a final consideration that I want to bring up here, though, and this is another thing that we came up with in our white paper, is that Intel also offers chips for different purposes. So they have the Xeon D, they have all the way multi-core or multi-socket chips all the way up to 8 sockets, for example. So kind of whatever you're looking for, there was a solution for you. AMD is really trying to challenge that by introducing multiple lines of Epyc processors that would fit into those various niches. And that's really important because previously AMD really didn't have a great competition all across the board. Now there looks like they're going to. Now, of course, this announcement is only the mainstream processors, but we do expect that they'll be announcing a whole line of processors for various purposes in the future. But there's one more factor to consider, and that's manufacturing. Essentially, what I'm hearing from actual data center architects and the folks that are actually building and deploying servers in the cloud is that another thing that's holding them back from ordering AMD is literally the availability of processors and components, supporting components, motherboards, and so on, because of the global supply chain shortage and because AMD doesn't control their own supply chain. It's dependent on TSMC and so on to actually construct these processors for them. And that's been a big challenge. And I think that that's going to continue to be a big challenge. So no matter how excited we are to say 96 cores and PCIe 5 and CXL, and no matter how great this product is, we have to temper it a little bit in terms of practical applications, power and cooling, availability, availability of complete solutions, et cetera, et cetera. There's a lot more that goes into a processor or a server decision than just the processor.
Absolutely, and maybe if I can throw in a last couple of comments. One of the first aspects is efficiency, sustainability. So you get those massive systems. You need to think about if it's a kilowatt, then you need to supply more electricity to your system. Of course, probably there's going to be more heating, more dissipation, more cooling needed. So I think it's kind of there's something that you need to factor in if you decide to go for such an architecture. I don't want to get too much into the details, but we spoke about that at Storage Field Day 24 last week, if I'm not mistaken, or 2 weeks ago. The other aspect, I mean, it's more a kind of a thought or consideration. There seems to be a kind of a runaway kind of trend to build more massive CPUs with more cores, more cache, and so on. And so, to me, it makes me think about what are we going to achieve there. Are we trying to get back to the mainframe era? Do we want to build massive CPUs that are going to be installed at hyperscalers or in large data centers? Are we going to get back to partitioning those and assigning slices of this and that? Maybe that's also what's going to happen with CXL composable infrastructure and so on. I don't know if it's where it's headed at, but it kind of rings a bell a bit on my side.
Yeah, that's actually really, really insightful, Max, because one of the things that CXL is promising and composability generally is promising is that we would be able to sort of mix and match and build the right server for whatever need we will, using this kind of composable hardware and more flexible hardware. We may be living in peak processor right now. This may be the biggest, baddest CPU we will ever see. Because if CXL takes off and if composability takes off, it will really change the balance of what we're looking for in a socket. Like, how many cores do we really want in a socket? If servers look different, if they're composable, if you can have like a rack of memory, a rack of processors, a rack of accelerators, and so on, and you can kind of mix and match as needed. Suddenly, this whole fight to focus everything into one socket, it really changes. So I would say from a nerd perspective, this is an amazing launch. It's an amazing product, and I'm really excited to have 128 or 96 now, but 128 soon x86 server processors in a single socket. Ooh, that's cool. But we may never live in this world again. Well, thanks for this discussion, Max. Those of you listening to this as well, I want to call out a couple things that are going on right now. A lot of my friends are at SuperComputing, which is happening right now. Just go to hashtag SC22 on Twitter, or visit the supercomputing.org website to learn more about that. Also, this week is Security Field Day. As we mentioned, Tom is in California with a bunch of the security delegates. Go to techfieldday.com to look for more from Security Field Day. And then finally, I'm going to call out, we at Gestalt IT just released a full-length white paper, Digital Infrastructure at Data Center Scale, which was sponsored by Intel. We urge you to download the paper at gestaltit.com. It's free, it's wide open. It would be nice if you signed up for the mailing list, but you don't even have to do that. We also released an accompanying Tech Field Day showcase presentation by the white paper writers, featuring folks, including Max, in the audience. So that's kind of fun. It's delegates presenting to their fellow delegates about this topic. So just go to techfieldday.com to learn more about that. Well, thanks for watching the Gestalt IT Rundown this week. You can catch new episodes every Wednesday on YouTube on your favorite podcast application. We will skip the next Wednesday because it's Thanksgiving here in the US, and that kind of overlaps with time off for everybody. But we'll be back the week after that for more IT news of the week that was. Until then, for myself, Max Mortellaro, Tom Hollingsworth, and all of us here at Gestalt IT, here's wishing you and yours a wonderful fast food-filled day.